Sunshine is now using real data thanks to the Open Weather Map API, and it's time for us to build up more of the UI. In this lesson, you'll learn how to create activities, create the structure of your app, and learn how to navigate between screens. And that means learning more about activities, the intent framework, and even learning how to use activities that come from other apps within your own.
Hey Dan, you want to see our weather app so far that we've been building?
Oh, pretty cool, but I want something more.
Well, we're not done yet. We just started 2 lessons ago. Give us a break. But fair enough, there's still a bunch more work left to do. What do you think we should do next?
Well, for starters, let's make the list item do something when you click on it.
Well, since you seem to be the expert on clicking on list items, why don't you do it? I'm gonna go eat some jelly beans.
I think Catherine was mocking me there. Speaking of mocks, let's go do some UI. Sunshine looks something like this, but it doesn't show most of the fun information we have about the weather. We want to show a detail view when the user clicks on a day within the list. Okay, that was a bit anticlimactic. It doesn't really do anything useful yet. But it will contain all sorts of great weathery details, things that weather nerds love, such as barometric pressure, and that navigators love, such as wind speed and direction. Eventually. But baby steps. From the mocks, we can see when a list item is clicked, we should perform an action to open up the details page for the forecast. How do we implement the click listener behavior? Take a look at the list view documentation. What method is used to wire up behavior on a list item when it is clicked? The answer is set on item click listener. We should register an on item click listener with the list view via the set on item click listener method. Then when an item in the list view is clicked, the callback is invoked. When the list item is clicked, use Android's toast mechanism to display the weather forecast string. A toast is a pop-up that displays a message for a few seconds before fading out. It's particularly useful for debugging, where it can be used as a way to indicate status visually without altering the app UI. We're going to put our list view, set item click listener, into forecast fragment, inside of the onCreateView method. We'll just start typing list view dot set on item click listener and let the autocomplete fill in the rest. Inside of this function, we're going to add click listener, which we can instantiate in place. So here's where we can call the code in Android to display the toast. So now that you know where to place the toast code, take a look at the toast documentation. Add a toast when the list item is clicked that contains the weather information. Hint: you can get the forecast by getting an item from the forecast adapter at the position given by the on-item click listener. Done already? Let me show you how it's done. As I said before, we get the forecast by calling getItem from the forecast adapter. And here's how we actually display the toast. Note that the context is actually available through getActivity in our fragment. However, it won't do anything unless we also show the toast. Displaying a toast is useful to see how an Android interaction works, but this method should really be used to start our detail activity. This is what we'll do next. You're going to use Android Studio to create the detail activity from the blank activity with fragment template. The template asks for the hierarchical parent of detail activity, which defines the up button, noted by the app icon, and a left-pointing caret here. But what does up mean? If you mapped out a hierarchy of all screens in the Sunshine app, the root of the tree would be the main activity, and its child would be the detail activity. So the up goes to the main activity. While the back button can achieve the same effect, it can also bring you back home or to another app depending on your history of screens. Up will always navigate you within the same app to the parent, regardless of how you arrived at this screen. Create the detail activity now, and look at how the activity is declared in the Android manifest file. We start by right-clicking on our package name to create the new activity from the blank activity with fragment template. So for name, we use detail activity. And again, the hierarchical parent of this class is going to be our main activity. So as you can see, We now have a new detail activity, along with the XML for activity detail, and a fragment associated with that activity. Great, you're done, but we still aren't launching our new activity.
To move from one activity, in this case the main activity in our Sunshine app, to another, here the detail activity, you call start activity. But note that when using the start activity method, rather than specifying the class name of the activity to start directly, that class name is packaged explicitly within an intent. The basic premise is simple. Whenever you need your app components to communicate with each other, or the system, you use intents to identify the target destination. Starting activities within your app is the simplest example. With your intent explicitly indicating the target using the context and the class name of the activity. Intents that use the name of the component you're targeting directly are known as explicit intents. I like to think of intents as envelopes. Each one includes who, or in this case, which component you want it delivered to, and there's room for a small amount of data to be delivered. Packaged as extras. Primitive tuples that will be available to the application component that ultimately receives and opens this intent. So an explicit intent explicitly specifies the name of the recipient, as you can see on this envelope. Implicit intents are rather more interesting. Here, we don't specify the name of the class. We don't even know what it is. So how do we indicate which activity to launch? Well, you know those stories you sometimes hear about letters with vague addresses, like these, that somehow still find their way to the intended recipient? Well, the intent resolution system on Android works the same way. Finding an activity capable of performing the action you specify on the associated data. So, rather than specifying the name of a class, you indicate an action you'd like an activity to perform and on what data that action should be performed. Like this, where we want to address an activity that's capable of viewing a website. And because intents can cross through application boundaries, the activity that started may not be part of your app. So, you can include functionality like this, browsing websites, or making phone calls, or choosing a contact from your address book, all from within your app without you having to implement any of it yourself. You don't even need to know about the app that will ultimately service your request. You can find details of some of the intents supported by native apps in Common Intents page of the Android developer site.
Thanks, Rado. Now that you understand what intents are in glorious metaphor, let's use them to do something useful. We'll replace the toast with an intent to launch the detail activity. You'll need to pass in weather forecast data for the detail activity to display. For more information, see the intent extra constants defined in the intent class. Great, you're done. The solution is to launch an explicit intent to the detail activity class. To pass in the weather forecast information, we can use an intent extra, which is a key value pair in the intent. We use the key name intent.extra_text, but we can use any string for the key, as long as we use the same key when reading the information out. Just as in the toast, we obtain the forecast data from the current list item by calling getItem on the adapter at the given position. Once the detail activity is launched, it shows Hello World. Instead, we want to read the forecast data from the intent and display it. Make the appropriate changes in the app so it matches the mocks, then verify the behavior by compiling and running the app. In the fragment detail layout, a text view is already defined. We have to assign it an ID, so that within the detail fragment of detail activity, we can use find view by ID to find the text view. To determine the forecast info that the text view should display, we can access the intent that the detail activity was launched by. We're going to use this inside of onCreateView. Since we added an intent extra with the forecast data there, we can read that intent extra back to display in the text view. As you can see, we pull the forecast string from the intent, find our root view, and then set the text to that forecast string. Woohoo! Clicking on a list item works.
Wow! know.
Our app is awesome,
Yeah.
but clicking on the settings menu does nothing. Wah wah. Hashtag sad trombone.
Don't do that again. Let me save you from Dan, and let's go build the settings now. Let's go through the wireframes for the settings UI. Within the detail activity in the overflow menu, there's a settings menu item. When you tap on the settings menu item, it opens up the settings activity. If you tap on location, it pops up a dialog where you can enter in your postal code. Feel free to use your preferred method for inputting location, such as city name. Just verify that the data coming back from the server is for the location you expect. Note that there's no validation on this string input. If you're trying to make this app a production app, you would want some type of error handling here. If you tap on Pick Your Units, it opens up a dialog where you can choose to display temperature within the app as either metric or imperial units. This is basically just Celsius or Fahrenheit. And that's what the settings activity does. Remember that you don't want to make everything a setting. If you're discussing a feature with a teammate and you can't decide on something, don't compromise by just making it a user setting. There are instances where making a difficult product decision now will be better for the user because then they don't have the burden of having to decide what the value of the setting should be. And remember, there's always an opportunity in an app update to add the setting later. If you add it to begin with, it's infinitely harder to take away the setting because some users might get angry with you. If you're having trouble deciding if something should be a setting or not, you can check out the settings section in the Android Design Guide, which is linked below. It contains a workflow diagram that could help you. Very few roads often lead to making something a setting. Open up the Developer API Guide for settings if you want to follow along. If you've pondered it carefully and you've decided you really want this to be a setting, this is what you do next. Android provides a way to display a hierarchy of preferences, including headers, such as the ones shown here. The value of the preference is called the preference summary, and that's seen here. It looks almost like the subtitle text. The preference also provides UI to allow users to modify that setting. You just need to supply the strings, but you don't have to implement the UI like the spinner here. Common preference types are the checkbox preference, list preference, edit text preference. We can see some examples in the Settings app under Developer Options. Here's a bunch of preferences. This is an example of a checkbox preference. This is an example of a list preference where you have different radio button options here. Once the user changes the setting, it gets saved in the default shared preferences file. This stores a bunch of key value pairs of primitive data. An example integer preference could be how many days of email history should be saved locally on the device. You could have a string stored in shared preferences for what the currently selected account in the device is. Then at any time you can fetch the value of the shared preferences as long as you pass in the name of the key that you want. You can also use shared preferences outside the context of settings as well. This information is located in the Developer API Guide for storage options, which is also linked below. We'll take advantage of what the framework offers in order to build our settings activity. Since we're supporting Gingerbread devices, we'll use the preference activity class. If you're targeting Honeycomb or later, you'll want to use the preference fragment class. Create a new settings activity class from the gist provided below. Update the Android manifest to declare this new activity. You can see the way detail activity is declared as an example. If you see that APIs are deprecated, that's okay. That's a side effect of using preference activity in order to target Gingerbread devices. When you create your app for your final project, you can use the wizard in Android Studio to create a new settings activity. The code the wizard provides will make your app backward compatible by using a combination of preference activity and preference fragment. Our gist is meant to be a simplified version of that for learning purposes, so later you'd be able to understand better what the wizard is doing. You check these items off when you're done. First we create our settings activity, and this is the code that we got from the gist. Then in the Android manifest, we declare the settings activity. We give it an activity named settings, which is declared in the strings file. We also declare the main activity as the parent activity. That way, when you hit the up button in the settings activity, it will return back to the main activity. Now it's time to launch the settings activity from the menu item. We need to launch it from two places, the main activity and the detail activity. Afterwards, compile and run the app to make sure that it works. This is what it should look like. From the main activity, if you tap on Settings menu, it should bring you to the Settings activity. it is expected for it to be blank because we haven't populated it yet. Now let's try the detail activity. If you tap on a forecast, you can go into the detail activity, and then you can go into the settings activity. Complete the task and then verify that your app behavior is like this. In order to launch the settings activity, we modify mainActivity.java in the onOptionsItemSelected method. When the settings menu item is selected, we create a new explicit intent to the settings activity class. We call startActivity to launch this intent. We don't call startActivity for result because we're not expecting a result from the settings activity. Similarly, in the detail activity class, when the settings menu is selected, we launch a new intent to settings activity. We have our settings screen, but no settings. In the next several sections, you're going to be adding our 2 settings. I'll walk you through how we add our first setting for location. Then you'll do the temperature setting on your own, so listen closely. First, we define a preference XML file. The root element should be a preference screen. In this example, we have a checkbox preference and a list preference inside of it. In order to add the preferences XML file to our app, we first need to create an XML folder under the resources res directory. Right-click on the res folder, go to New Android Resource Directory, and then type in XML as the name of the directory. For resource type, you can choose XML, and then hit OK. Inside this folder, we right-click to create a new XML resource file. We call it pref_general, and the root element is a preference screen as we saw on the developer site. And then our preferences file is created. Then add the location preference. Since the wireframes showed an editable text field to input user location as a string, we make this an edit text preference. If you want to learn more about all the possible XML attributes, you can Google for edit text preference. First, we specify a title for the preference, which will be the label that's displayed to the user. Then we specify a key, and this key is actually the key value in shared preferences. Going back to the code, we also add these attributes to describe the edit text field in the pop-up dialog that was shown in the wireframes. Going back to the code, we can also configure properties of the edit text field. We specify the input type to be text, and we cap it to a single line of text. It's bad practice to hardcode these strings here, so we declared them as constants in the strings.xml file. These are the strings we declared. This is the name of the label of the preference. It's user visible, so we add a char limit for translation purposes. We also specify location, which is the name of the key in shared preferences. We don't want to translate it because we always want to find the key based on this name. We also specify a constant for the default location. We also don't translate this because we need to send it to the server API like this. When you're done with these steps, check them off and continue. To make the preferences appear on the phone, we need to modify settings activity. In the onCreate method, we're going to replace this to-do with some code. We're going to call add preferences from resource with the pref_general XML that we defined. Then we need to bind the preference summary to the value of the location preference. This means that when the user changes a preference, the summary value underneath the label will be updated. If you look at the declaration of this method, we see that for a given preference, it sets a preference change listener on it. If you scroll to the top, you see that the settings activity actually implements the interface onPreferenceChangeListener. That method is found down below where we override the onPreferenceChange method. Remember that our location preference is actually an edit text preference. So it won't fall into this case, but it will fall in this case down here. Then in the settings UI, you can see that the summary is now this value. Make these changes in your app. See the instructor notes for the lines of code you need. Once the user's location preference has been stored, when do we make use of it? We need the preferred location when we query the weather service. Luckily, in Lesson 2, we modified fetch weather task to accept a location parameter. We hard-coded it to be the Mountain View zip code, but now we should use the location stored in shared preferences. We haven't explicitly shown you how to do this, so you might need to do some digging around on the Android developer site to figure out how to do it. Once you've made the change, check the box to continue. Within the forecast fragment class, when the refresh menu item is selected, we read from shared preferences. Since they are key value pairs, we get the value stored for the location key. If there's no value stored, then we fall back to the default location. Then we pass the location into the fetch weather task. On app launch, I know that you're probably tired of seeing the dummy data and needing to hit the refresh button for real data every single time. I'm going to show you how to display the data using the current settings each time the activity is loaded. In forecast fragment, we just refactored the code so that when the refresh button is selected, we call this helper method update weather. Now that it's in the helper method, we can also call it from the onStart method. We override onStart so that the refresh happens whenever the fragment starts. This will cause the weather data to appear. We'll learn all about onStart and the rest of the Android lifecycle in the next lesson. At this point, we can also remove all the fake data that we had in the onCreateView method. Then we pass in an empty array list to the array adapter. Now we can test this. We need to make sure that this is the first app launch and that it wasn't already running. So if it's already running, kill it, and then tap to open the app, and then you should see the actual weather data immediately. Under settings, we can change the location to be the Paris postal code. We hit OK, and then return to the main list, and then we see that the weather data has updated. Now it's your turn to build the temperature unit setting. This will bring together a lot of the concepts that you learned and will take some time to implement, but we think you're ready for it. Modify the app so that the right temperature units are displayed to the user. Use the assumption that we're syncing metric data from the server. Eventually, we'll have a database on the device, and we don't want a mix of Fahrenheit and Celsius data in there. Hence, we'll stay consistent by getting metric data from the server, and then we'll convert on the fly to the preferred units when we update the UI. After you make these changes, I'll show you what it looks like on the device. If you go to Settings, you'll see the temperature units preference. If you tap on that, you see a dialog with two options. If you switch to Imperial and then you go back to the forecast list, then you see that all the temperatures now are in Fahrenheit. Once it works, answer this question. Which subclass of preference did you use? The solution to this question is List Preference. When the setting is tapped, it presents a list of choices as a dialog. When the user selects an option, it's saved into Shared Preferences. Here are the steps to do this. Within the pref general XML file, we add a list preference. We give it a title, and this maps to the string temperature units. We also need to give it a key for the shared preferences, and so we specify that to be units. If there is no value in shared preferences, then it falls back to a default value of metric. The preference also wants to know the list of all possible values here. The two possible values are metric or imperial, so we pass those in as an array into entry values. Now these are just constants for use within the logic of our app. These are not the user visible strings. So we need to create entries, which is an array of user visible strings that maps to each one of these possible values. To have the temperature unit preference show up in the settings activity, we modify the onCreate method. We add this line of code for the temperature unit setting. When the user makes a selection in the dialog, we set the preference summary to be the new value of either metric or imperial. Here, when we receive a high and low temperature, we read from shared preferences to know whether the temperature should be converted to imperial units or left as metric. Then we return the formatted string for display in the UI. That completes the code for saving the temperature unit setting. I'll show you how we can add breakpoints in our code. Go ahead and click on this green bug icon to attach the debugger. We'll go to the settings menu. In the settings activity, I'm going to add two breakpoints in the onPreferenceChange method. I'm going to add a breakpoint at line 59 in the case of a list preference when it's about to set the summary. I'm also going to add a breakpoint at line 63 when it's not a list preference and it sets the summary. Let's go into the app to try it out. Tap on the location and change the postal code. If you hit OK, then it triggers the breakpoint to stop at right here. These are the values of the variables at this time, and we see the new postal code here. You can step over or into the method for more details, or you can hit play to continue or stop to stop the debugger. Let's hit play to continue. And then we see that the UI has been updated so that the preference summary is the new postal code. Let's try it for temperature units. We tap here and then select imperial. It triggers this breakpoint in the list preference case. We hit play to continue, and then we see that imperial is now the preference summary.
Hey Dan, we finished the settings. Do you want to check it out?
Oh, great.
Wait, what's with all this stuff right here?
I'm glad you asked. All this stuff will help me demonstrate the power of implicit intents, leveraging other apps to get functionality for your app for free. For example, why would you write a barcode scanning app when you can just launch an intent to do it for you? Or a camera app when you can just launch an intent to fire a photo? And of course, it would make no sense to write a phone app just to dial a phone number. You would just call the intent.
Wait, I need that.
In other words, don't reinvent the wheel. Lazy programmers make fewer mistakes. Now let's go implement an implicit intent.
Rado? Dan's being implicit again.
Add a menu option to view the user's preferred location on a map. It will be handled by any Maps app that's available on your device. If there is no map app on your device, handle this case gracefully to avoid a crash. You might want to recall that we use shared preferences to store the preferred location. Done already. Let's go to the solution. In the menu layout file for the main activity called main.xml, we add another menu item that will always be in the overflow menu. We also define the string in the strings.xml file. The menu will be inflated in the main activity class, so we can handle the map menu item being inflated by calling a helper method called openPreferredLocation in map. The helper method reads the user's preferred location from shared preferences. Then we create a view intent indicating its location in the data URI. The format of the data URI was from the documentation page on common intents, where you can append a postal code as a query parameter. Finally, we start an activity with this intent. Note that we only start the activity if the activity resolves successfully.
So how did the system know that the Maps app could handle this intent? The activity within the Maps app included an intent filter, like this one, within its manifest entry. It indicates that the Maps app is capable of performing this view action on all data which has a geo scheme. You can use intent filters for your activities to define the actions they're capable of performing and optionally the kind of data that they can perform it on. So when you use an implicit intent to address a request to start an activity, much like you did with Catherine and the openweathermap.org link, Android resolves this request by checking the intent filters of every activity that's installed on the device until it finds the best possible match. If multiple activities match, as in the case with a web URL, the user is given a choice.
One of the most used implicit intents in Android is the share intent. It's awesome. It's a great way to waste time for both you and your friends. Dan. You can leverage your favorite apps to share photos, text, videos, and general links. And the best part is you don't have to even know what the user's favorite apps are. Just tell Android what data you want to share, and it shows your users a list of apps that will share it. Apps that may not have existed when your app was written. To make it even easier to share, Android 4.0 added the Share Action Provider, and we have it for previous releases of Android as part of the support library. It operates using the action send intent. If we use Rato's glorious envelope metaphor, it would be addressed to anyone who can perform action send. The data to send would be included with it as extras, either as text or URI to the binary data, and the MIME type would indicate what the URI points to. Here's what the Share Action Provider will bring to our app in glorious wireframe. There will be an additional icon in the action bar, which will drop down a menu when clicked to reveal potential share actions. Another icon will be added to the right of this one that contains the last application shared to. Add a Share Action Provider to the fragment within Detail Activity. It will share weather in the following format. Yes, it's just the string we passed into the view plus #SunshineApp. Here's our coding solution for the Share Action Provider. Let's start by adding a string. The string will be used for the label for our action. Now we're going to add a new menu resource. This resource will be for the detail fragment. We'll start by adding the namespace used by the Android support library for its widget XML. Finally, we add the actual item. This menu item contains the string that we just added from the strings file. It's always shown as an action, so it appears on the action bar. And its action provider class is the Share Action Provider from the Android support library. The Android support library allows the Share Action Provider to be used on earlier versions of Android than 4.0, when it was officially added to the framework. Next, let's go to the detail activity. We're going to be looking at the detail fragment within the detail activity. So the first thing we can do in our fragment is to add a few useful things. Let's add a log tag, a string for the share hashtag, #SunshineApp, and we're going to take the forecast string and make it a member variable. Next, in onCreateView, let's actually populate our member variable. And then finally, use it to set the text. Let's create a share intent. This intent uses action send. This flag activity clear when task reset is somewhat important. It prevents the activity we're sharing to from being placed onto the activity stack. What will happen if we don't have this flag is when you click on the icon to return to the application later, you may actually end up in another application, the one that's actually handling the share intent. When flag activity clear when tag reset is used, it'll actually return you to your application instead. We set the type text plain to let Android know we're going to be sharing plain text, and then we share our forecast string plus our hashtag. Only one more thing left to do. We have to add the menu to the fragment. To do this, we have to set a flag that this fragment has an options menu at all. Otherwise, it won't actually call the onCreateOptions menu member function. Finally, here's our onCreateOptions menu member function. As you can see, we're inflating the detail fragment menu that we created earlier, finding the share item, getting the share action provider, and attaching our intent to the share action provider. You'll want to update this whenever the data you want to share changes. And that's it. You've now added a share action provider into Sunshine.
We've talked about using intents within Sunshine to start activities and send data between apps. But what if you want to broadcast a message to many apps? For example, the system will broadcast a message saying that the device is charging or that it's just finished rebooting. To do that ourselves, we use the sendBroadcast method to broadcast an intent, and those broadcasts are received by broadcast receivers, typically referred to as simply receivers. Using intent filters like the ones we saw earlier, they indicate which broadcasts they're interested in. So if we return to our envelope metaphor from earlier, in the case of a broadcast intent, your envelope is basically addressed to any broadcast receiver that's interested in knowing that this event has happened. And it does that using an intent filter. So intents which are broadcast are transmitted to every app with a broadcast receiver that has an intent filter telling the system, your ideas are intriguing to me and I wish to subscribe to your newsletter. As you can see, the receiver itself is pretty simple. Extend the broadcast receiver class and override the onReceive handler, as you can see here. Receivers are lightweight components meant to listen for broadcasts, react and complete within 5 seconds. That usually means simply starting a service or sending a notification. To have your receiver start listening for broadcasts, you need to register it, either through an entry in your manifest like this, or dynamically within another application component, usually an activity like this. Then you define the intent filter that specifies the broadcast event you want to receive. You can do that either here in the manifest, or if you're registering your receiver with an application component, such as an activity, you can create your new intent filter like this. The biggest difference between manifest and dynamic receivers is when they're triggered. A programmatically registered receiver will only receive broadcasts while the app is running, while a manifest declared receiver will start your app specifically to receive your broadcasts. For example, I usually code with my noise-cancelling headphones on, so a music app like this might want to register a runtime receiver to listen for the system intent broadcast that announces when headphones are unplugged. That will allow it to automatically pause playback when the audio routing switches from headphones to speakers. In this case, we can use a runtime receiver because the app is guaranteed to be running if music is playing. On the other hand, if I'm using Google Cloud Messaging to listen for new data from my server, I'll want to register a manifest receiver that always listens for incoming tickles from my server and will wake up my app if it's been terminated to trigger the update code, usually a sync adapter, which is something we'll discuss later in Lesson 6. There's a bunch of system broadcasts you can monitor to help your app react to changes in the system. You can see the system broadcast actions within the intent documentation at developer.android.com. One great use for broadcast receivers is to monitor for changes to internet connectivity or charging status. Imagine your app has to upload a movie or calculate the next 10,000 moves in a game of chess. How might you use a receiver to wait until the device is plugged in before starting that process? Should it be a manifest receiver or a broadcast receiver? You could register a listener for the Action Power Connected event, and you should do that within your manifest. And that way it can be called to start your app once the device is getting charged, even if it's been terminated since the last time you were using it. You can use a similar approach to delay trying to send data until the device has internet connectivity, or to change behavior of the user experience when you're connected to a car or desk dock. In this lesson, we added new activities to our apps and explored ways to structure and navigate between them. And that meant learning all about intents and how they're used in Android. Next up in Lesson 4, we're going to learn about the activity lifecycle and make our apps that much more useful by saving data. We'll dig into databases and learn about content providers, but first, let's take another journey into the history of Android.